Hello, my name is Rob Humfeld. Welcome to the JSMA Learning Series videos. I'm excited to share with you a powerful LabVIEW software framework that I use every day for every application. It's named JSMA, and you can download it for free at the link below. JSMA is a modular software framework that allows you to quickly create, easily extend, and efficiently maintain a LabVIEW application. That means that JSMA will help you create software that's better for you, better for your coworkers, better for your users, and better for your bottom line. I've created these videos to help you understand the basics of JSMA framework and to quickly start developing your own applications. This first video will be focused on explaining the background information that you need to understand the core concepts of JSMA. So, how does JSMA help you to create better LabVIEW applications? In case you're not familiar with the software engineering concept of coupling, I need to explain it here briefly. As described in Wikipedia, coupling is the degree of interdependence between software modules. In other words, it's a measure of how closely tied together two routines are. It turns out that although tightly coupled code may work great at first, it's actually incredibly difficult to modify without breaking the application. That's because any change in one part of the code will likely affect many different parts of the code. So ultimately, it's best to write loosely coupled code. In other words, software comprised of modules that are minimally interdependent. JSMA's key innovation is to base its framework on a simple-to-use publish-subscribe messaging architecture. This allows developers to easily write code that's loosely coupled. How would that help developers, you ask? Well, let's dive in by talking about the challenge that we face as software developers trying to write good code in an environment that may include changing requirements, changing stakeholders, and changing team members. The best solution to this challenge I have seen was in a talk given in 2010 by Norm Kirchner, who referenced an idea presented by Tim Jones called s'mores. According to this idea, you need to write good software as described by the anagram s'mores. In this case, S is for scalable, M-O is for modular, R is for reusable, E is for extensible, and S is for simple. My goal in writing JSMA was to create a framework that anyone can use to create a LabVIEW application that meets this s'mores description. Again, S for scalable, MO for modular, R for reusable, E for extensible, and S for simple. So what are the JSMA core concepts and how do they compare to this s'mores ideal? First, we'll start with the MO, modular. A JSMA application is modular by design. Your JSMA application will consist of multiple modules that are each responsible for different aspects or tasks required of the software. The modules will run concurrently. As an example, a simple data collection application may consist of a data collection module and an operator interface module. The data collection module will continuously communicate with the I/O hardware to get the data. The operator interface will present the data to the user. Okay, great. We got the modular part down. Give me an MO for modular. That was pretty simple. But wait a minute. How would the data get from the data collection module to the operator interface module? Well, the core value of JSMA is how it solves exactly that problem. JSMA uses messages to allow modules to send data, commands, status updates, notifications, or basically anything between the modules. This is where the first S, scalable, comes in. JSMA uses a class to define a message. Each type of message is a child of that parent JSMA message, but it has its own unique name and a set of specific parameters associated with it. You may not be very familiar or comfortable with LabVIEW classes, but with JSMA you can leverage their power without difficulty. We'll talk about the details in depth in our Introduction to JSMA Messages video. But the great thing about classes is how extensible they are. Anytime that you need another message, you can create a new child class. Because JSMA uses the message class, all the different types of messages can be sent and received in the exact same way despite their differences. And you can have any number of different message types defined for a given application. So for our example, JSMA will handle sending a start message with no associated data from the operator interface module to the data acquisition module. as well as sending a data packet message with data from each input signal from the data acquisition module to the operator interface module. Now, do you want to have separate data packet messages for analog inputs and for digital inputs? Fine. Create two different messages with different parameters. JSMA allows you to have any number of different messages in the system. Giving an S for scalable. Timeout. Remember coupling? What about that? At this point, you may be ready to challenge the claim I've made about JSMA and loose coupling. If I have an operator interface module that sends a test start message to a data acquisition module and a data acquisition module that sends a data packet message to an operator interface module, that sounds tightly coupled, doesn't it? Well, the key here is to understand more about what happens when JSMA sends a message. With JSMA, when a module sends a message out, it actually does not send it directly to the module. In fact, the module sending the message does not even know which module, if any, are going to get the message. Instead, the module calls a JSMA VI to send the message. You see, JSMA maintains a subscription list for each message type. The JSMA VI that sends the messages looks up the subscription list for the message, then directs the message to any and all modules that have subscribed for it. JSMA handles all the subscribing and the distributing of the messages. Each module only knows about its own messages and that it sends and processes, and does not know or care about the other modules in the applications that send and receive messages. Let's explore this idea further by considering an analogy. Let's talk about Twitter. When Katy Perry has a new song she wants to promote, does she email each and every one of her fans individually? No. No, she sends a tweet to Twitter. Twitter then feeds that message to all 106,937,266 of her followers who subscribe to her feed. Yeah, I looked it up. And even though you may subscribe to and get all of her messages, she actually doesn't even know or likely care who you are. Sorry. So JSMA works like Twitter? Well, sorta, but not really. Because with Twitter, you subscribe to the feed of the producer of the messages. The producer generates any number of different kinds of messages, and you get all of them that the producer generates. But if Twitter were to work like JSMA, it would look something more like this. You are interested in a certain type of messages. Let's, for this example, say messages about the NFL. Katy Perry, she would still tweet like crazy, and others would too. But you're not really interested in the producers, you're interested in the topic. You may not even know who the producers are, but you're going to get all of the messages about the NFL that you can. So in JSMA, a module subscribes to a specific type of message and then receives every one of those messages regardless of its producer. In this sense, it's a little like following a Twitter hashtag rather than a Twitter account. Back to our example application. The data acquisition module subscribes to receive the test start message, but it doesn't know that the operator interface is sending it. The operator interface module subscribes to receive the data packet message, without knowing that the data acquisition module is the one sending it. So the only links that exist between these two modules are the two messages themselves. You could change anything about the operator interface module without considering its effect on the data acquisition module. For example, maybe you add a trend plot to your original dashboard of dials on the operator interface module. Or maybe in the data acquisition module, you decide you're going to oversample an average to smooth your data out. The two modules are minimally coupled, and that's a real plus, as we've discussed before. To prove that, assume we developed a RIO acquisition module. Maybe it uses CRIO instead of CDAC to collect the same data. If the new module receives the same test start message and sends out the same data packet message, what would prevent us from swapping the new module in for the old one? The answer is nothing. Because these two modules are minimally coupled, we can swap the new one in without affecting the other modules already in the application. Now that you understand the core JSMA messaging concept, what implications does that have? First one is that any given message could have only one subscriber. It could have 20, 50, it could have 0. Any given message could have one producer, or it could have even more than that. Modules could join or exit the application at any time during execution. And no module would be inherently dependent upon any other module. That would mean that you could write modules in parallel, maybe different people working on them at the same time. You'd be able to independently modify modules without considering the effect on others. And what we found is that debugging often becomes a lot easier. Again, the key concept is no module knows or cares what other modules may be running. It only knows about the messages that it sends and receives. Doesn't that all sound good? Like a s'more. Now, if you got your head wrapped around that key concept, let's return to s'mores. E stands for extensible. An extensible system is one whose internal structure and data flow are minimally affected by new functionality. Another way to think of it is that extensibility can be seen as a measure of the level of effort required to implement said extension. So let's examine how extensible JSMA is. We've just explored how JSMA modules are very loosely coupled and neither know nor care about the existence of the other modules. So extending an application should be a breeze, right? Extensions to a JSMA application are often accomplished by adding a new module. You simply subscribe your new module to send out and receive the appropriate messages. Once your new module is up and running, JSMA will handle routing all these messages to and from other modules in the application. To clarify, let's again use the example of the simple data collection application. Let's say it's been up and running for a while and the customer decides you need to add some alarm monitoring capability. What do? Where do you put that functionality? With JSMA, this problem is really simply solved. You create a new module called Alarm Manager. It subscribes to the data packet message, which is being sent out by the data acquisition module. When it gets the data, it will evaluate the data looking for alarm conditions, and when it finds one, it needs to notify the application. How would you handle that? Well, you create a new alarm condition message. It will contain information about the alarm that was triggered and or cleared. What module is going to get this new message? Well, at this point, when you're writing the Alarm Manager module, you actually don't know or even care. Your Alarm Manager module is complete, and you did it without having to change anything about the other modules in the application. The next step would be to have the operator interface subscribe to this new alarm message and present the alarm condition to the user on the screen. That's simple to do as well. But wait, now your customer comes back, and they want the user to be able to configure the conditions of the alarms. What now? Well, you'd probably start by creating an alarm configuration message that the Alarm Manager would subscribe to receive. Then you'd make your Alarm Manager handle the message by updating the alarm conditions. Next, you'd have to decide how will the user input the alarm configuration information. Do you want to just include those messages on the existing operator interface? And so in that case, it would be the one to send out the alarm config message. Or do you want to create a new alarm configuration interface module to send the new message out? And if you want to display the alarm configuration during testing, the operator interface can subscribe to that data as well. However you decide to do it, JSMA makes it a breeze. It's easy to see from this example how using the JSMA framework supports writing extensible software. Give me an E for extensible. Using JSMA is also simple. Subscribing to receive a message is merely a matter of modifying a single cluster. To send a message, you only need to use two VIs, one of which creates the message, the other of which sends the message. To receive a message, you also have a two-step process. You create a case and a case structure, and you call a single VI to extract the message data. And to make all this even simpler for the developer, JSMA has wizards which will create modules and messages for you. Each of those takes about 5 seconds to use. After you watch the other introductory videos, I'm sure that you'll see in detail that how it's done is very simple. Give me an S for simple. If you're still with me, you may already be able to see how JSMA also supports developing reusable code. It's the power of the decoupling. Decoupling means minimizing dependencies, and dependencies are the main obstacles to code reuse. If we minimize the dependencies, we can maximize the reuse. JSMA modules are easy to write to be reusable because the only links that they have to other modules are the messages themselves and any application level resources that they may share. Each message is in its own class, so it could be used in any number of projects as well. Proof that JSMA supports reusability could be found by considering reuse in our example application. Different reuse packages could potentially be extracted from this application. Perhaps you would pull out a data collection package, or maybe an alarm management package, or just a simple message library package. How much work it takes to actually make these packages general use rather than project specific, it'll depend a lot upon how you implemented the module functionality. But I hope that you see at its core, JSMA gives you all the tools that you need to create code that's reusable. Give me an R for reusable. So that's the introduction to the core concepts of the JSMA framework. Let's see, S for scalable, MO for modular, R for reusable, E for extensible, S for simple. I can confidently declare that JSMA is s'mores compliant. I hope this video was helpful in both understanding JSMA concepts and in evaluating whether JSMA could be right for you. We've been using it for years and it's proven its value time and time again, so I hope you'll give it a shot. You may be excited about the potential of using JSMA. What next steps are available to you? Well, you could check out the rest of our JSMA Learning Series videos that would give you some insights, or you could just jump in, download the JSMA base, and try it out. If you need to, you can contact us directly to see what additional services we could provide. Anything from custom training, project consulting, architecture design, code development, turnkey systems. However we can help, just let us know. All the links for this can be seen below. If you enjoyed this presentation, please like this video and feel free to leave a comment below, and be sure to check out the other videos in the series. Thanks for your time and have a great day.